So there are a number of applications in which we can use clustering algorithms. So here are three examples in which the clustering algorithms are being used most commonly. So one of these problems can be for search engines, right, like Google or any other search engine. In any search engine, they try to group similar objects in one cluster and provide results for the search data according to the nearest similar object, which are clustered around the data to be searched. So in a search engine, a clustering algorithm can be used to cluster the results against a search query, right? And then they can be grouped with each other with the nearest similar objects. Similarly, as I told earlier, that we can use clustering algorithms in order to perform email spam classification or detection, right? So in spam detection, we take the initially labeled spam and general data and apply clustering on the entire data set. The unlabeled spam items will end up in the clusters along with the labeled spam items. Using the labeled spam data, we can then label the unlabeled data in the same cluster. Thus, it helps us separate unlabeled data into spam and genuine. So you see that what we can do is we can use some labeling data and unlabeled data in order to perform spam detection and classification. And as I told you, for the number of clusters or for the value of k, for spam detection or classification, we can have two clusters in which one cluster will be forming the emails which are classified as spam, while the other emails can be considered as the non-spam cluster. And the third category or third example, which is a most commonly used application of clustering algorithms, is to perform customer segmentation, right? So in telecom providers can cluster prepaid customers to identify patterns in terms of money spent. This would help the company target specific clusters of customers for specific campaigns. So these were just the three practical applications in which we can use clustering to perform different types of tasks. But there are many other applications which are using clustering algorithms in order to perform different types of problems and in order to in order to enhance their business. For example, for market analysis, for customer generations, and in banking, and also in medical science, there are a lot of applications in which the clustering algorithms are being used. So in this course, for our clustering domain, which is our unsupervised learning domain, we will basically covering three main algorithms. One of these algorithms is k-means clustering, other is k nearest neighbors, and then expectation maximization. Both these algorithms can be used in order to form clusters, but we will start by looking into the k-means clustering algorithm. And today in this lecture we will have a basic introduction of k-means algorithm, and then we will move on forward in more detail, in more depth of k-means in next week, and then in the coming weeks we will be covering knn and em algorithms, and both three algorithms can be used to perform clustering. So let's have a basic look at the k-means clustering algorithm. In k-means clustering algorithm, this is basically the outline of this lecture, which makes you able to know that after this lecture you will be able to understand the concept of clustering, and in particularly the k-means clustering. You will be able to explain and write your own k-means clustering algorithms, and you will be able to understand diverse or different examples by which are using k-means clustering, and then you will also be able to understand different challenges which the k-means algorithms face, and how these problems are being solved by k-means through different variations in them. So we have already seen and we have already had some detailed discussion on clustering, and we now know that we are trying to find clusters, or we are trying to find groupings between different objects, and our aim is to have high intra-cluster similarity, and on the other hand we also want to have low intercluster similarity. So what is this intracluster similarity and this intercluster similarity? So if you look at this figure, you will see that this dotted line in yellow is basically show the intraclass cluster, right? Because we have one cluster here and we have one cluster here, and between these two clusters we have this intra-class clustering, right? So this is intra-class clustering and the other is within this cluster, so that's why it is named as inter-class cluster. So now we want to have this intra-cluster similarity to be high, and on the other hand we want the inter-cluster similarity to be low as much as possible. So again, we have seen that clustering is important in a number of applications. For example, market segmentation and summarizing news, and also in order to discover different properties and different attributes present in certain types of data. Another example which uses clustering is for the web documents, such as I told you, it happens in a search engine. So they are basically performing clustering against different queries and then providing a group of information after doing this clustering. And we also looked into the supervised classification, unsupervised classification. We have now understand fully the basic difference between two domains, and we also know that when we have to use which algorithm in which problem. So we have also seen these cluster and clustering differences. Another example is can be seen from in this figure, in which you can see that we have some scatter plots of different types of data, and which is the original unclustered data, right? So maybe this portion can belongs to some different attributes of data, or maybe this portion belongs to some different attributes of data. And through clustering algorithm, I can basically see that which data points in this whole scatter plots, which points belongs to which property or which attributes. So I can execute a clustering algorithm on that, and that clustering algorithm can basically form 3 different clusters on the basis of different attributes or properties of this data distribution, right? Now we have seen that we can form these clusters by using 2 different distance measures. One is similarity based distance measure and the other is dissimilarity based distance measure, and both of these measures can be used to perform clusters. Now in similarity measures the degree to which a pair of objects are alike, right? So we are trying to calculate the degree to what extent the pair of objects are resembling to each other. Concerning structural patterns represented as strings or sequences of symbols, the concept of pattern resemblance has typically been viewed from 3 main perspectives. So what are these 3 perspectives? Number 1 is that similarity as matching, according to which patterns are seen as different viewpoints, possible instantaneous or noisy versions of the same object. So this can be one viewpoint. Another can be that the structural resemblance based on the similarity of their composition rules and primitives, and the third one can be based on the content based similarity based on their attributes and properties. So we have already seen 2 distance measures. We have seen their mathematical formulas through which we can calculate these distance measures. One was Euclidean distance and the other was Manhattan or city block distance. But there are 3 other distance measures which people are using to perform clusters, and those 3 distance measures are cosine distance measures and Tanimoto distance measure and the squared Euclidean distance measure. But out of these 5 distance measures, the most commonly used distance measures are these 2 distance measures which we have already seen. One is the Euclidean distance and the other is the Manhattan distance. So in the next lecture we will see 2 or 3 different examples of k-means algorithm. We will see different components, the whole algorithm, its flowchart, and then we will try to understand it with different examples. And after k-means clustering we will move on to some other unsupervised learning algorithms. to fully understand the clustering and unsupervised learning domain. Thank you very much.